Hello beautiful people and welcome. In this video we will be discussing our exponent rules and we're going to be doing a few examples. As always, if I make a mistake, I am human. Please let me know where the mistake occurs so that way I may learn from it and you may learn from my mistake as well. Let's get started with the product rule. Now the product rule, when you hear the term product is the answer of something that's being multiplied. So when we're doing product rule, we have, let's say we have a base of x, we have an exponent of a, times the base of x, exponent of b. Now for the product rule, note that the bases have to be the same. If the base is not the same, we cannot do this, or we cannot apply the product property or the product rule. However, if the bases are the same, we keep the same base, we take the two exponents and we add them together. Let's do a quick example of this. So if we have, I don't know, let's say h squared times h to the 6th power, we will have h to the 8th power. Let's do something that's numeric. Let's say 2 cubed times 2 to the 5th power. Oh, I didn't do that on purpose. But it's 5, 6, 7, 8, so we have 2 to the 8th power as our answer. So that's how you apply the product rule. For the power rule says that, hey, if you have a base raised to an exponent of a number, it doesn't matter what number. You have an exponent, you have a base. Now, the base and exponent are now being raised to yet another exponent. So you have an exponent on top of an exponent. When you have that, the way you're going to treat that is you're going to take the base, in this case our base is x, and you're going to take the two exponents and you're going to multiply them together. For example, if I have x to the 5th power and that's being raised to the 10th power. So x to the 5th power being raised to the 10th power. I'm going to say I have x 5 times 10, which means I have x to the 50th power. You're going to multiply that. Now, this here is going to be an example with multiple terms. So negative 2m to the 5th power, and I'm going to square that. This here is the same thing as saying negative 2 to the 1st power times m to the 5th power, and all of that is being squared. Multiplication is king. You're going to learn that the higher you go in math. Multiplication and division are kings. So because we have 2 times m, we need to separate them out just a little bit. Now that we have them separated out, we can apply this power rule to both terms. So I'm going to say negative 2 times 1, negative 2 to the 1st power times 2, and m to the 5th power times 2. I'm taking that 2 and I am applying the power rule to each term inside. So now, what do we have? We have negative 2 squared times m to the 10th power. Now, since we have numerics here, we can solve this or simplify this further. So I have negative 2 squared, which is negative 2 times negative 2, which is 4. Then I have my m to the 10th power. So it doesn't matter how many terms you have on the inside. You have to, if they are being multiplied, again, multiplication is king. If you have addition or subtraction, it fails. You can't do that. Addition or subtraction makes this power rule fail. Only multiplication and division. Okay, quotient rule. This is where the and division came from my last statement. For the quotient rule, if you have a base being raised to an exponent and it's being divided by a base being raised to an exponent. Now again, for this to work, the bases have to be the same. It can't be 5 and 8. It has to be 5 and 5. Bases have to be the same. So if the bases are the same, what you're going to do is you're going to take that one base and you're going to take the numerator exponent, so the one on top, minus the denominator exponent, the one on the bottom. Top minus bottom. Let's do a quick example here. So if I have, let's do 6x to the 5th power divided by, let's do 24x to the 10th power. We're going to separate this out just like we did here because we have multiple terms. So how do we separate them out? I'm going to have 6 times x to the 5th power, and for the denominator I have 24 times x to the 10th power. I cannot apply the quotient rule to stuff that doesn't have the same base. We can, however, separate them out because multiplication and division are key. Multiplication is key. We have multiplication here, therefore we are able to separate them out like this, and we're able to continue to separate them out like this. So 6 divided by 24, and we have x to the 5th divided by x to the 10th. Now that I'm able to separate them out, I can simplify each fraction separately. So 6 divided by 24, 6 goes into 6 once, 6 goes into 24 4 times. Then I am applying my quotient rule, which says I'm keeping my same base. Here's my base of x. And I'm going to subtract my numerator and my denominator. So numerator minus denominator. So therefore, what do I have left? I have 1 over 4 times x to the 5 minus 10, negative 5th power. And I'm actually going to leave this here because of our next property, or our next rule. Negative exponents. I love how that worked out. Negative exponents. For negative exponents, let's do a base. Let's do base of x, and let's say we have a negative exponent. Now, what the negative exponent means, it tells you that the base and the exponent belong in the denominator. So you are going to take the x and the negative, and you're basically going to take the reciprocal of the base and flip it. So in this case, I'm going to have 1 over x, take the reciprocal of the base, and our exponent goes onto the base in the denominator without the negative. The negative just tells you, hey, you belong in the denominator. So for example, let's take this one here, for example. If I have 1/4 x to the negative 5th power, my base here is x, my exponent is 5. Yes, it is negative, so that means that x to the 5th power belongs in the denominator. But now I already have 1/4, so that means my actual answer for this question above should have been 1 over 4x to the 5th power. Let's do one more example. And let's do 4r cubed over 2r, 16. So let's separate this out just like we were doing with the quotient rule. So we have 4 over 2 times r cubed over r 16th, exponential power 16. Running out of space here, that's okay. 4 divided by 2, that is 2. Now we have r3 minus 16, which is 13 negative. So 2 times r negative 13. So that means our base of r and our 13 belong in the denominator. The 2 does not have an exponent that is negative, so therefore the 2 does not belong in the denominator. 2 has an exponent of positive 1. So we have 2 over r to the 13th power as our answer for this example. The very last property here is called the zero exponent rule, or the zero exponent property. You'll hear rule, you'll hear property a lot interchangeably. So if you have a base with an exponent of 0, now this is a really interesting property. I encourage you to YouTube it, watch a bunch of videos as to why this is the case. But anytime you have an exponent of 0, the answer is 1, always. So I'm running out of space here, so let's do a really quick example. Anytime you have an exponent, so like for example 7w to the 0th power, 2r to the 0th power. That means I have 7 times 1 times 2 times 1. And so my answer, let's do our answer this way. 7 times 1 is 7. 7 times 2 is 14. 14 times 1 is 14. Our answer here is simply 14. So now let's take all of these properties, all of these rules, and apply them to some examples and simplify some things. For example 1, let's do 5x cubed times y divided by 20x y to the 5th power. And all of this is going to be raised to the 4th power. So there's a lot of things that's happening in this example, so we need to split it up. Multiplication is king. Remember, anytime you see adding or subtracting, you're having a heart attack. You only want multiplication to make these easier. So let's separate this out. 5 times x cubed times y divided by 20 times x times y to the 5th power. And then all of this, you can use brackets or parentheses, is being raised to the 4th power. Remember, for your quotient, every single term gets that exponent. So what I really have is 5 to the 4th power times x cubed to the 4th power times y to the 4th power. So this 4 is going to each term. And again, if you see addition or subtraction, you cannot do that. All of this is now over 20 to the 4th power times x to the 4th power times y to the 5th power being raised to the 4th power. All right, so let's go ahead and simplify this. 5 to the 4th power, we're going to keep that just for right now because I don't have a calculator right in front of me. I'm going to separate the numbers, times. Now I'm going to do using my power rule, which says if I have an exponent being raised to the exponent, I'm actually multiplying them. So 3 times 4 now, divided by x to the 4th power, times y to the 4th power, divided by, again using that power, 5 times 4. Again, I'm going to leave the numerics for last. X to the 12th divided by x to the 4th times y to the 4th divided by y to the 20th. Now we have division. We have quotients, right? We have division. So what did the quotient rule say? The quotient rule said if I have the same bases, I'm going to subtract numerator minus denominator. So I'm going to say I have 5 to the 4th power over 20 to the 4th power, leaving that for last, times x, 12 minus 4 as my exponent, times y, 4 minus 20. Bring this down. I have 5 to the 4th power, 20 to the 4th power, times 12 take away 4. I think that's 8, 9, 10, 11, 12. So that's 8 times y. 4 take away 20. That means I'm going to have a negative, and that is a negative 16. Alrighty, I'm going to shift over to the left here. So I have 5 to the 4th power over 20 to the 4th power times. Now notice this is now positive. X to the 8th is positive. Now positive means that it belongs in the numerator. So x to the 8th is in the numerator of my fraction. This here is negative. And because the exponent is negative, the base and the number of the exponent belong in the denominator. So I'm not actually bringing the negative with me. The negative just tells you, hey, put it down at the bottom. So I've dealt with that. The only thing I didn't deal with is the numeric. So let me find a calculator here. Five to the 4th power divided by 20 to the 4th power. And I get 1 over 256. And you don't want decimals here. If you get a decimal, do it by hand. And I'm going to omit the 1, leave the 1 out because we don't need it. It's just 1. 1 times x to the 8th, and this is 256, times y to the 16th.